Hello, my name is Steve Bowler, and in this video I'm going to be configuring MPLS VPNs. So what we're going to do in this lab is we are going to explain the topology, and then we're going to go into the routers and start configuring them. As we can see, we have a headquarters router and a branch router to simulate our customer connections. And on the ISP network, we have ISP R1, R2, R3, and R4. Within the ISP network, we are going to be running on all of the interior interfaces. We're going to run EIGRP and MPLS. Our links to our customer, we are going to be running RIPv2 between them, between the premise edge, which are ISP R4 and R1, and the customer edge, which is the headquarters and branch router. So ISP R3 and R2, they are called P routers within our MPLS network, and their main purpose is to just switch the MPLS labels. So they are not going to be having to do a lookup, or they're not going to have the connections to all of the other networks. They're just going to be switching based on labels. So again, that's what we are going to be doing. Is we're going to be participating in routing with the customer. So we have, this is a peer-to-peer VPN. You have two types of peer-to-peer VPNs. You have a shared VPN, a shared router VPN, peer-to-peer, and we have separate router VPNs. Shared router is where all your customers share the same router in a geographic area, and then the ISP participates in the routing with the customer. However, you can imagine in that type of environment, trying to keep each customer separate and filter will be very difficult. You're going to have to filter a lot of routes and a lot of ACLs. So the shared router peer-to-peer VPN is not very desirable. We also have separate router VPNs where each customer has their own router, and as we can tell there, unless you have a lot of money that you have to throw out, where every customer has a router, that can get very expensive to have the ISP manage all that for you. So what they have come out with is what's called MPLS VPNs, is where you have multiple customers, like in a shared peer-to-peer VPN, where you have multiple customers connected to the same router, and they can be implementing RFC 1918 filtering or IP addressing, where everybody uses separate IP addressing, but the router is going to keep all this information separate in each routing table on the router. They do this by creating what's called a VRF for each customer, or what's called a virtual routing and forwarding instance. So this is how they separate the traffic logically on the router, by using multiple routing tables. Each routing table for simulate each customer. So they will also, what we will see, a new type of BGP, what's called multi-protocol BGP. This is for more advanced implementations of BGP, which is multicast BGP or we're going to be running VPN v4 in this case between ISP R4 and ISP R1.